Air, water, and equipment. In this module, you will examine some features of the environment in which you will be diving, learn about some indispensable pieces of skin diving equipment, and discover how light and heat behave beneath the surface of the water. Air and water. The world we live in is a physical, tangible reality, and everything that belongs to it has substance, meaning that it is made up of real elements. These elements in our minute world are called molecules. The entirety of the molecules that makes up a single body is called the mass. Each person has his or her own mass, and the larger a person is, the larger the mass, because a greater number of molecules is needed to form the body. The things around us also possess other properties. A solid, for example a stone, has a mass. It occupies a well-defined quantity of space, known as the volume, and it also has its own form. Now, if we examine a liquid, for example water, we immediately discover that although it has both mass and volume, measured in liters, it doesn't have its own form, but it assumes the shape of the container it is in. Gases, such as air, have only mass, and have neither a form nor a volume of their own. Let's prove this. Let's take two cylinders with two plungers, one filled with water and one with just air. Now, by pushing down the plungers, we discover that by increasing the force, we manage to reduce the volume of air in the cylinder. We are compressing the air. Instead, with water, however much we push, we cannot compress it. Gases, therefore, are compressible, while liquids and solids are practically incompressible. The difference is caused by the fact that in liquids, as in solids, the molecules are very close together, and it is difficult to push them any closer. On the other hand, the molecules in gases are farther apart, and with sufficient force, it is possible to push them closer to one another. The presence of a greater number of molecules makes water about 800 times denser than air. Fins. Besides the heavier weight, the greater density of water also produces other effects. Imagine running along a beach and going into the water. The higher the water gets, the more difficult it becomes to run, and the only way to move is by swimming. When you run in air, you have to overcome the resistance that this gas opposes to your advancement. In practical terms, this means that you have to move the molecules of air in front of you and make others move in behind you to occupy the empty space left by the movement of your body. In water, you have to move a much greater number of molecules. For centuries, man explored the underwater world by walking on the sea floor, and only recently have divers learned to swim underwater. This is thanks to a fundamental invention: fins. Manufacturers produce fins that are basically a blade combined with a shoe. If you have strong leg muscles, you can use fins with a rigid blade, which are much more efficient. Otherwise, it is best to use fins with more flexible blades to avoid the risk of getting leg cramps. The ideal fins for free diving are those with long, rigid blades, but these are only suitable for those who are very fit because they require strong leg muscles.